Hello all. Today I'd like to talk about dimensions, unit, and unit conversion. So before I start with, I'd like to talk about quantities. So overall there are three basic quantities. We call them fundamental quantities. So those fundamental quantities are mass, length, and time. So we have more fundamental quantities that they are more into electrical side of it, something look like current. So that they will be covered later on. So for mass, I'm going to call it the dimension for capital M. I'm going to call the length capital L, and then calling time capital T. So MLT stands for mass, length, and time. So in the SI system, the unit for mass is kilogram, the unit for length is meter, and unit for time is second. Similarly, in the English system, the unit for mass is slug or pound mass. So LB stands for pound. And then we have the unit for length is feet, and the unit for time is the same as second. So if we talk about derived quantities look like area. So area can be written as length times length, which will be equal to L square. So the dimension of area is L square. So in SI we can use units like meter square, millimeter square, and in English system units like feet square and inch square. The derived quantities for volume will be length times length times length, something like L cube or meter cube, centimeter cube, feet cube, inch cube, yard cube, mile cube, so whatever to the power of 3. Density is about mass over volume. So mass over volume density means that how heavy something is in the same volume. For instance, if you have 1 meter cubic of ice, is it heavier or 1 meter cubic of water? So if you look into the dimension of it, will be m over L cube, because we already know mass is m. The volume, we prove it to be L cube, so it will be m over L cube. Now you can say something look like kilogram per meter cube, gram per centimeter cube in SI, and into the English system something like pound mass over feet cube. The next one is velocity. So velocity is equal to length over time, something like L over T, meter over second, meter per second, or centimeter per second, kilometer per hour. Into the English system would be feet per second and inch per second, mile per hour. Acceleration is changing in velocity over time. So if we are accelerating in our car, means that how our speed is increasing with respect to time, how fast we are speeding. So the unit for this is, if we talk about the dimension will be velocity in the numerator, which is L over T, over the time, and the resultant will be L over T square. So meter per second square, kilometer per hour square, feet per second square, mile per hour square. Let's talk about more derived quantities. So more derived quantities is something like force. Force is mass times acceleration, second law of Newton, and then we can write it is as m L over T square. So we just proved it that this is m over L square. The resultant will be ml over T square. So the unit for force in SI will be kilogram meter per second square. That we just simply call it Newton. We don't need to carry that name for that. In English system, the unit for that is slug feet per second square. We just simply find that pound force for simplicity and for simplicity purposes. So pressure is force over area, which is will be F over A. So into pressure, we can say we already derived the force, which will be kilogram meter per second square, or ml over T square. So we can substitute it from here into here, and then we already know that area is L square, so pressure will be mL over T square. So in SI, we call it kilogram per meter second squared. It's called Pascal. In English system, pound per inch square, we call it PSI. So it's pound per square inch. Now atmospheric pressure is 100,000 Pascal. This is just a brief example of talking about under what pressure we are living. We are living under 100,000 PSI. So if you do the calculation on 1 meter square of object, the calculated force will be 100,000 Newton. So we are almost under 100,000 Newton of pressure for every meter square. So let's talk about work. Into the work, we already know that work is, should have a displacement to have a work. In this example, I have three forces, F1, F2, and F3. If you look into this picture, you would see F2 doesn't produce any work. If the intended direction is the arrow, we want to move this way. So F2 will not create any work. So overall work is force times displacement. And then if I simplify it, would be force, which you already know it, ml over t square. And then we're going to get ml square over t square. The unit for work called joule. Very simple. Or you can call it Newton meter. Because if we have here the force unit for force is Newton, the unit for displacement is meter. So the other thing that we can say, 1 joule is equal to 1 Newton meter. Power is work or energy over time, and then if we simplify it, we'll get to something like ml square over t cube. We don't care about that, but just knowing that the unit for in SI for power is joule per second, that we call it watt. Temperature, we often use three different temperature: degree Celsius, degree Fahrenheit, degree Kelvin. And then into the unit conversion, we know that degree Fahrenheit is 1.8 C plus 32, and then the Kelvin is equal to degree Celsius plus 273.15. So from here on, I would like to go briefly over unit conversion, how we calculate unit conversion. So in SI unit, the good thing about the SI unit is that everything is in a multiplier of 10. So if we start from going up, we have kilo, which is a kilo is 10 to the power of 3 or 1000. You can hear about megabyte or mega is 10 to the power of 6. Then we have giga, which is 10 to the power of 9. And then deci is 1 over 10 or 10th. Centi is 1 over 100 or 10 to the power of minus 2. Milli is 10 to the power of minus 3. And as we are going smaller, micro is 10 to the power of minus 6. Nano is 10 to the power of 9. And pico is 10 to the power of minus 12. In English system, the conversion is very odd, but just go over one of them. 1 feet is 12 inch, and 3 feet is equal to 1 yard. There are more in there. So in order for us to do unit conversion, we use dimensional analysis. So in dimensional analysis method is a very easy method. The only thing, the way that works is that you need to draw different fraction for it. But before you start with, we need to know what we need to have. So in this example, the first example, the question asks us for 40 kilometer per hour to convert it to how many meter per second. So I want to convert kilometer into meter and convert hour into second. So on the side, I know 1 kilometer is 1000 meter, and I know 1 hour is equal to 3600 seconds. So into the calculation, I know that when I say 1 kilometer is 1000 meter, so the ratio of 1 kilometer over 1000 meter will be 1. So I can simply multiply 40 kilometer per hour that I have here times 1000 meter per kilometer. So why I put kilometer down? Because you should put it down to allow it to cancel it out. So you can cross it off with the kilometer here. So this kilometer here will be crossed off with kilometer here. Now in the other side we have an hour. We have hour in the numerator, the denominator. In the other side I'm going to put the hour in numerator, so allow the hour to cross off, and 3600 second into the numerator, and the resultant will be 11.11 meter per second. Second question asks us to convert 9 kilometer per liter into how many miles per gallon. So on the side, I know 1 mile is equal to 1.6 kilometer, and 1 gallon, US gallon, is equal to 3.785 liter. So into this conversion, so we put 9 kilometer per liter in the first one. So I wanna go get rid of kilometer in the numerator. So what I'm gonna do in the other side, I'm gonna put the mile up, kilometer down. So allowing this kilometer to cross off with each other. So to better show you, I meant this one to cross off with this one. So we can get rid of it. In the other side, the liter will be gone, and the answer will be 21.17 miles per gallon. Part C. For part C, the question asks us to convert 554 meter quad divided by day kilogram into centimeter quad over minute gram. So we know that 1 meter is 100 centimeter. 1 day is equal to 1440 minutes, and 1 kilogram is 1000 gram. So the way that we put it in, we know that for us, because meter is up here in the numerator, so I'm going to put the meter in the other one in to the denominator, so allowing this meter here with this meter here to cross off. But the only problem I see is that, okay, I put 100 centimeter up and I put 1 meter down, but here is meter to the power of 4 and here is meter to the power of 1. So what we would do is that we will raise everything to the power of 4. So by raising everything to the power of 4, I would allow to create meter to the power of 4, and in the answer I would allow to create centimeter to the power of 4. Remember, the ratio of 100 centimeter over 1 meter is 1, so 1 to the power of 4 will be again 1. And then in the other side, I'm going to use 1 day on the numerator because I want to get rid of this day with this day here. And then the kilogram here is in denominator, so I'm going to put the kilogram here is numerator. So now if we look into what cross off with what, the leftover will be centimeter to the power of 4 over minute gram, and then you can multiply them, you will get this answer. So there are 3 more parts to these questions. Convert 38.1 feet per second to meter per second. The only useful equation is 1 feet is equal to 0.348 meter, that you can simply use it. The next question asks us for 921 kilogram per meter cubic to pound mass over feet cube. So the conversion which is given to us is 1 kilogram is 2.28 pound mass. We already have the feet over there, so I did not repeat it. And very last one is feet square over hour. You want to convert that into centimeter square over second. So the useful equations are 1 feet is this many centimeter and 1 hour is 3600 second. Thank you for watching this video.